I'm Charis, your physics teacher in Senior 6, and you're welcome on this content of Senior 6. Remember, we are dealing with sound waves. But let us talk about factors that affect velocity in sound waves. Previously, we explained very well there are three factors that affect velocity of sound waves. 1. Compressibility. 2. Density. 3. Temperature. But let us do some examples which may help us to understand the formula that you are using when you are calculating the velocity of sound waves. Wow! Find the speed of sound in water which has Buick modulus of B, which is equal to 2.1 times 10 to the power 9 Newton per meter squared, at a temperature of 0 Celsius degrees, at the density of 1.00 times 10 to the power 3 kilogram per meter cube. Remember, we have seen the formula. Let us check. The speed is equal to the square root of Buick modulus divided by the density. This can be calculated by taking the square roots, of Buick modulus. We have it 2.1 times 10 to the power 9 Newton per meter squared. So that is 2.1 times 10 to the power 9 over 1.00 times 10 to the power 3. Remember, this square root is over this fraction. It is not only on 2.1, it is over this fraction. So you might be having calculators. Please take your calculators and calculate this. Could you check whether you are getting 4 kilometers per second? Please calculate it. So this is how you can apply this formula. But when you have the question, if you don't know the formula that the velocity is equal to the square root of Buick modulus divided by the density, you cannot be able to solve this question. But you may ask yourself, here it was in water. What about in solids? Find the speed of sound in copper, with Young's modulus of 2.0 times 10 to the power 9 Newton per meter squared, with a density of 4 times 10 to the power 3 kilogram per meter cube. The gain is the same, apart from changing from Buick modulus, you replace it by Young's modulus, and I think you have seen it. Then the speed will be equal to the square root of Young's modulus, that is 2.0 times 10 to the power 9 over 4.0 times 10 to the power 3. Let me show you how, if you have a challenge with your calculator, there is a way that you can do this. For example, can I simplify 2 by 4? Very simple. Here I remain by 2, here I remain by 1. By using property of powers, I can take this 10 to the power 3, it becomes 10 to the power -3 when it moves up. Then it will be 10 to the power negative 10 to the power 6, because that is 9 minus 3. Then this will be equal to the square root of 1 over 2 times 10 to the power 6. When you're using still the property of powers here, 10 to the power 6, when you move the square roots, this will be equal to this will be equal to square root of 1 over 2, then times 10 to power 3. Then by using the properties of irrational numbers, that is the square root of 1 over square root of 2, then times the square root of 2 over square root of 2. Is it not interesting? Now we are coming back to mathematics, but still this is physics. Now I will have then times 10 to power 3. This will be equal to square root of 1 still it is 1, that is square root of 2, then square root of 2 times square root of 2, that is 2 over 2 times 10 to power 3 meter per second. Very interesting. If you don't have a calculator, you may express this one in terms of rational numbers. So these are examples which are showing you how I can calculate the velocity if I have the Young's modulus, if I have the big modulus, but also remember there is another formula where you can calculate the speed as the initial speed times square root of final temperature over initial temperature. Please find a question where you can apply this formula, then you will check whether it is very interesting as long as you have the final temperature, you have the initial temperature, but also you have the speed of sound in air. Remember, this VO in air is equal to 331 meter per second. What if you can talk about production of sound waves? Is it not interesting after talking about characteristics, talking about properties, what if you can talk about production of sound waves? You may be giving some examples on your own where sound waves can be produced. When you are hearing me, am I not producing sound waves? Great. Production of sound waves. Sound waves can be produced by different materials. We have pipes. Sound can be produced by pipes, by guitar, by piano, and most of us we are very familiar with these materials which can be produced, which can produce sound waves. Then etc. There are other materials that can produce sound waves. But very interesting how this one can produce sound waves. Let us take an example for pipe. Then later we shall talk about guitar, piano, and do some examples relating to sound waves. Pipes. Let's take a pipe, okay? And this pipe, it is producing a sound like this, like this, like this, okay? And if this pipe is closed, okay, the distance from here to here, this will be the wavelength. Remember, there is a formula that links the speed with the wavelength and the period. And when you are talking about propagation of sound waves, we have seen that they can propagate in solids, in gases, and in liquids. And we have seen that there is a way that we can find the speed. So If the speed, for example, is equal to square root of Birk modulus divided by the density, this should be equal to, for example, let us use Young's modulus because it is in solids. Let's take for this case of pipes. Now, this one will be equal to wavelength divided by period. I'm wondering if they're asking you to find the Young's modulus of material. Some of you from senior 6 you are going to be engineers because you are doing physics. When you are going to construct a house, you cannot construct it with a material, a metal, without knowing its Young's modulus. Now, how can you calculate it? Because you need to know these values. What if I can square both sides? Okay. Now I have Young's modulus over the density is equal to wavelength squared divided by period squared. Cross multiplication, now I have T squared times Young's modulus, okay, which is equal to wavelength squared times the density. Now this Young's modulus will be equal to wavelength squared times the density over the period squared. Very interesting. So this is, some of you will find in these materials it is written Young's modulus, but this is how it can be calculated. So if you are going to construct your house, if you are going to construct the soundproof, you need to know the Young's modulus of materials that you are using, which is very interesting. So thank you very much. You can find us on YouTube channel, which is Ikaram TV, okay? Ikaram TV. And like this channel on YouTube. Subscribe on this channel on YouTube, please. But also you can find our contents with other units, which is www.ubumenyi.net. Thank you very much. Next time we are going to continue production of sound waves and giving some real examples about production of sound waves, but also doing some exercises which are helping us to understand very well the production of sound waves, but also to find basic formulas that we are using when we're explaining production of sound waves. Thank you very much. I love you. We feel okay when you understand, when I'm getting your feedback from our website www.ubumenyi.net, but also by subscribing on Ikaram TV, because we want to help you to understand physics in real life, but also to help you to pass your national exam. Thank you very much. Ciao, ciao. I'm Charis.